Hey class, welcome to Chapter 11, Probability. Today we will be looking at Exercise 11A, a review of theoretical probability. So the probability of an event occurring can be described as a decimal, fraction, or percentage, all of which lie between 0, which means it's impossible, or 1, certain, where the probability of an event occurring, which we shorthand to PR bracket event, and you name the event in that, equals the number of favourable outcomes, so that's the event that we're looking for, out of the total number of outcomes, or how many possible outcomes there are. When we talk about the sample space, we're looking at what all possible outcomes are. So for example, the outcomes of a coin toss are heads or tails, which we write in squiggly brackets and then as a list. So H for heads, T for tails. The complement of an event A is the event where A does not occur. So the complement of tossing a head is tossing a tail. So you're either going to flip a coin and land on heads, or you're going to flip a coin and land on tails. So those two complement each other. You might have the roll of a die and you are looking at the probability of rolling a number 1. Okay, so there's one on a standard die with 6 sides, so 1 out of 6 chance of rolling a 1. You have a 5 out of 6 chance of rolling the complement of that event, which is not a 1. When you add the probability of one event occurring and its complement, so the event of it not occurring, you should always get 1. So either that event will happen or it will not. Let's try a few examples. We're going to first list the sample space and then calculate the theoretical probability of each of the following events. So the first things first, to list the sample space of we're rolling a number 6 in a standard die. So the sample space of a die roll are 1, 2, 3, 4, 5, 6. So that's our sample space. And the probability, I'm trying to line it up under the part 1 and part 2, the probability of rolling a 6, so PR for probability of rolling a 6 in brackets, is given by, we've got this number 6 occurs only once in this sample space, okay, out of a total number of 6 possible options, okay. So there is one side on a dice with the number 6 on it, assuming it's a standard dice, and 6 sides total. You can then write that as a percentage or as a decimal if you would like, but in this case, fractions are going to be much neater because our denominator is a 6. Let's try another example. We're going to randomly select the letter M from the word mathematics. So our sample space is M, A. So if I had a bag of Scrabble letters and the letters specifically, I could spell mathematics if I emptied them out or in that bag. These are the possible things that I could draw. So M-A-T-H-E. M has already been listed in the sample space, so we don't repeat it. A has already been listed. T has already been listed. I has not been, C has not been, and S has not been. So those are the possible options, knowing that I could draw 2 M's, 2 A's, or 2 T's. The probability of selecting a letter M, there are 2 M's in the word mathematics, and we have a total number of letters. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters in the word mathematics. Okay, again, keeping it as a fraction because it's a lot simpler and neater than writing 11ths as decimals. Okay, so in the sample space, we don't repeat the letters if they appear more than once, or if there was a standard die and it was a trick die and the number 6 appeared twice, then it would be 2 out of 6 or 1/3. Okay, so you need to be careful with the sample space, not to repeat the letters, but refer back to the total sample to find the probability. One last example, we want to find the probability of drawing a blue marble from a bag containing 3 blue, 4 red, and 7 green marbles. So I can either draw a blue marble, a red marble, or a green marble. That's my sample space. I'm going to draw one of those 3 colors. At the end of the day, it doesn't really matter which one I draw out. I'm going to draw one of those 3. If it helps you to visualize this, I can draw a funny looking bag of marbles. All right, that's my bag. I've got 3 blue marbles. I've got 7 green ones. And I've got 4 red. Alright, so that's my marble bag. It does not matter which one I draw out. I'm only going to be interested in the particular colour of the marble that I draw out of the bag. So the probability of drawing a blue marble from this bag, we've got 3 possible blue marbles out of a total of 14 marbles. Again, that does not simplify. You could write it as a decimal or as a percentage if you really wanted, or you can leave them as fractions in their simplified form if you need to simplify them. Okay. One last little note that I want to make for you all today, I'm going to just erase the marble bag, is that the term equally likely means that each outcome has the same chance of occurring. Okay, so for example, when you roll a dice, it is equally likely that you will roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Okay. However, the term even chance means that there is a 50-50 chance of it occurring. So if I'm rolling a dice, there is an even chance that I will roll an odd number, as there is for me rolling an even number. So I can either roll a 1, 3, or 5. If I'm only looking at whether the roll is odd or even, that's a 50-50 chance. Okay, but each individual number has an equal chance, or is equally likely of being rolled. Flipping a coin, heads and tails are equally likely. Okay, they've both got a 1 in 2 chance of being flipped on each toss, but they also have a 50-50 chance. So they each have a 50% chance of occurring. Please be careful not to confuse those two. And that concludes today's lesson. As always, guys, if you have any questions, let me know. But otherwise, good luck with the work, and I will speak to you all very soon.